In this tutorial, we're continuing our deep dive into FreeCAD. Now, in the previous tutorial, we covered the UI, workspace navigation, material colors, and 3D lighting. And we even got some hands-on experience with the basic primitive. Now, we'll pick up where we left off and we'll start working with shapes and geometry. But first things first, let's just make sure that we're starting from a clean slate here. So your model tree should be empty except for the reference images that we added in the last tutorial, and they should be tucked away in a folder like this right here. Also, if in the last tutorial you added a cube shape to your project, you can delete that now as we don't need it any longer. Now in this tutorial, we're going to start building the base of this moon lander, this low profile box shape right here. Now, if you haven't already, you can download the 3D reference image and the flattened 2D trace geometry using the free resource link in the description below. Or if you'd like to create your own custom 2D geometry from a product image of your choice, the CAD sketch tool within Lightloop can do that for you as well. Again, all of this is optional. We're dealing with such simple geometry right now for this tutorial that you'll be able to follow along even without the reference images. So one of the hardest conceptual shifts for people new to FreeCAD is learning how to see a 3D object as a collection of 2D shapes. So whenever you have a vision for a product, for example, like this one, the first question you need to ask yourself is, what are the underlying 2D shapes required to create this 3D form? Okay, so let's just jump straight into an example here. Start by adding a new body to your project by clicking on the Add Body icon right here. Now, an example body will appear in the model tree with an associated origin point. All bodies in FreeCAD have their own origin point, and this will come in handy later once we need to start using this invisible coordinate system to help us align parts within each subpart of our product. Now, these bodies act as sort of a container for parametric features, things like sketches, pads, and pockets. This will help us maintain a linear step-by-step history of how the final object is built. Again, I'm getting a little ahead of myself right now, but this is just something to keep in mind as we move forward. Now, generally speaking, you'll use different bodies for different parts within your product or for each distinct independent shape. What this is going to do is it's going to allow for independent parametric editing of each part. Okay, so let's go ahead and rename this body to Moon Lander Base using F2 on our keyboard, or we can just right click and select Rename. As always, you can toggle the origin points visibility on and off with the visibility icon right here, or by pressing spacebar on your keyboard. Now, the next step is completely optional, but as I mentioned previously, if you like to practice tracing geometry, head to the free resource link in the description, download the reference images and add them into FreeCAD, place them into a folder called Reference Images just to keep things organized. Again, to add images, click on File, then Add, and then simply double click on the added reference image and orient the image along the XZ plane. Okay, we'll click on OK from here. And then what we can do is we can orient ourselves to the front view by pressing the number 1 on our keyboards. Okay, so again, you don't really need these reference images to follow along, but having them visible will give you a sense of the bigger picture. Okay, so let's get started here. So what we'll do is we'll toggle the reference image on, and you'll see the first shape we need to create is this wide, flat box at the base of the lander. So that's where we're going to begin. So first, turn on the coordinate system by clicking on this visibility icon here. Now, you'll likely need to reposition your reference image so that the coordinate system sits at the base of the moon lander body right here. So to do this, just double click on the reference image and then adjust the Y distance value until the origin point lines up roughly with the bottom of the lander, somewhere around here. And then once you're done, just click on OK. Okay, now let's get into the main workhorse of FreeCAD, which is this sketch tool. It's the red and white icon with 2D shapes on it right here, and it's where you're going to be spending the majority of your time within this software. This is also where all of your underlying 2D geometry will be created. Now, before we go any further, there's one critically important thing to understand. Within the sketch tool, you can create 2 completely different types of geometry. First, we have model geometry, sometimes referred to as sketch geometry or profile geometry, which is the geometry that actually defines your 3D shape. Think of it as the physical form that you're trying to bring into the world. And then there is construction geometry, which is invisible reference geometry used purely as a guide. It never becomes part of your final model. Now you switch between the two using this little toggle icon right here. Now when you're in model geometry mode, the sketch icons are red and white. And when you switch it to construction geometry mode, these icons change to blue and red. Now it's very, very easy to forget which mode you're in, and if you accidentally create construction geometry where you meant to create model geometry or vice versa, you'll be hit with a wave of error messages when you try to run any operations. Now fortunately, there's a second visual indicator beyond the icon colors which let us know which mode we're in. So for example, any construction geometry that you draw will appear with dashed lines, while model geometry will always appear with solid lines. Now, before moving on, just make sure your construction geometry setting here is disabled. Your sketch icons should be red and white. And when you're ready, just click on Close to go back to Part Design. Now, before clicking on this sketch icon, let's first click on Front View to orient ourselves. Now, what we'll do is we'll click on this Sketch tool. You'll notice the coordinate system becomes visible, showing the planes that represent the different axes here. Now, you can hold your mouse button down and rotate around to get a better look, but essentially, FreeCAD is asking you which plane you want to sketch on. Now, if you already have CAD experience, the concept of sketch planes will feel very familiar to you. If you're completely new to CAD, however, it can be a little confusing at first, so let's just take a quick moment to break this down. A plane, sometimes called a construction plane, a datum plane, or coordinate plane, is essentially an invisible flat surface that you can sketch on. Think of it like a sheet of glass floating in 3D space. There's no model geometry there, just a defined surface to draw on. Now, importantly, planes are never part of your final product. They're purely invisible guides. Now, to make this clearer, let me turn off all of my reference images here. Now, look we just kind of exist in this kind of three-dimensional void. There's no surfaces here, there's no geometry, and we don't have anything to draw on. And that's exactly the problem that a plane solves. It gives you a flat surface to anchor your 2D sketch to. Now let me show you how this works in practice. So after clicking on the sketch tool, you go through a simple two-step process. First, you choose the plane that you want to sketch on, and then you create your sketch. So let's complete step one now. Now I'm going to select the XY plane because this represents the base of our moonlander right here, and I want to build upwards from that point. Now once you select a plane, notice that the toolbar icons along the top change entirely. You'll also see from the navigation cube that FreeCAD has automatically reoriented your view to look straight down at the selected plane from the top. Okay, so let's start by adding some 2D geometry to this plane. Click the drop-down arrow next to the rectangle tool and select this option here for centered rectangle. Now, hover over the center point of the plane. You'll notice a small icon appears. This is a constraint indicator, telling you that your starting point will snap to this vertex. If you hover over one of the access lines instead, like right here, the icon will change to indicate that your starting point will snap to that edge. Hover over any empty area on the canvas and those indicators disappear entirely. Now let's put this into practice. Click on the center point to begin drawing your rectangle. Now as you move your cursor outwards, notice that the shape scales dynamically and the current dimensions are displayed in these input fields right here and right here. However, rather than eyeballing the size, let's enter our dimensions manually. Let's type 110 and press enter for the width here. And then we'll enter 110 and hit enter again for the height. Now this will give you a perfect square centered on the origin point. Now after hitting enter again, notice that the shape has been created and it has turned entirely green. And this just means that it's fully constrained. It's locked into place and cannot be moved or resized by dragging. And this is because two things are defining it. The center constraint we applied when we first placed the shape on the canvas here, and the two-dimension values of 110 that we just entered. Now the only way to change those dimensions now is by clicking directly on the values and typing in new ones. But for now, let's just keep these set to 110 and 110. You'll also see a confirmation in the properties panel over here that this sketch has been fully constrained. And as a rule, green geometry has been fully constrained. And as a general rule, this is going to be exactly what you want. Now, one thing to note here, the centered rectangle tool that we use to do this is still active. So if we clicked anywhere on the canvas right now, we would start drawing another rectangle. So let's pause here for a moment before we do anything else, because I have to share a couple of quick notes with you. So to deactivate or drop a tool at any time, simply right-click on an empty area of the canvas. Notice that after I do that, I'm not sketching rectangles any longer. Also, if you accidentally added an extra shape, you have a couple of options here. So the quickest is just to press Ctrl Z on your keyboard to undo. Alternatively, with no tool active, you can click and drag over any unwanted geometry and then just select it here. And then what you can do is you can press Delete on your keyboard to remove it. Okay, now for the sake of learning, let's take a look at what unconstrained geometry looks like. So select the standard rectangle tool from this drop down now, and then draw a rectangle anywhere on the canvas that isn't touching any existing geometry. This time, don't enter any values manually, just click to place it and then right click to drop the tool. Notice that you can now grab any edge or corner of this shape and drag it freely. Also notice that the shape is white rather than green. This is FreeCAD telling you that your shape is underconstrained. So if you look at the properties panel over here, you'll also see a message indicating that this sketch has 4 degrees of freedom. That said, this doesn't mean that you always need to constrain your shapes immediately. There are times, especially early in the design process, where you need the freedom to move things around before committing to dimensions. Now, in most cases though, you should generally speaking be working towards fully constraining your geometry. So let's continue with our example here. So let's just say that we're ready to commit to the dimensions of this top edge here. So first, click somewhere empty on the canvas just to make sure that we don't have anything selected, and then activate the dimension tool by clicking on this icon right here, or what you can do is simply press D on your keyboard. Now click the edge that you want to dimension, then move your mouse out slightly to position the dimension label, and then left click to place it. Now you'll be prompted to enter a value. Type in your dimension here and then hit enter. Now notice that this shape now has only 3 degrees of freedom instead of 4. You can still move the shape around freely, but you can no longer modify that constrained edge by dragging. To change it now, you need to click directly into the dimension value and then type a new dimension. So let's go ahead now and just delete this shape. What we're going to do is we're going to right click to drop any active tools. We're just going to drag to select the shape and then we'll press delete here. Okay, so now let's add another rectangle, again, just for the purpose of learning. But this time what we're going to do is we are going to select this rectangle tool and then we are going to hover over one of the existing lines on the canvas. Notice the constraint indicator that appears here, letting you know that if you start your sketch from here, the new rectangle will automatically be constrained to this line. So go ahead and click to start the rectangle there. Just drag it out to your desired size and then right click to drop the tool. Now don't enter any values manually this time, just drag and drop. Notice that this shape now has 3 degrees of freedom. You can resize it freely, but you can't move it off the line that it's anchored to. So within FreeCAD, working with under-constrained shapes is perfectly fine. FreeCAD will let you proceed without complaint. However, you'll run into errors if your geometry becomes over-constrained. Now, this happens when you apply conflicting or redundant constraints to a shape. So for example, if you've already constrained an edge to a specific length, and then you try to apply a second dimension to that same edge, FreeCAD can't satisfy 2 potentially conflicting or different rules for the same element at the same time. So it's going to flag this operation as an error. Now, these overconstrained errors are some of the most common messages that new FreeCAD users encounter, and they're easy to trigger without realizing it, especially when you're adding dimensions one by one and you just lose track of what's already been constrained. Fortunately, the fix is really straightforward. When an overconstraint occurs, FreeCAD will display an error message identifying the problematic constraint by name. It will also show the overconstrained line geometry as orange over here. You'll also see the conflicting constraint highlighted in your constraints panel here. So all you need to do is simply locate it within the list here, click on it, and then press delete to remove it. Now, once the redundant constraint is gone, your sketch should return to either fully constrained or under constrained, both of which FreeCAD will be more than happy with. Now, we'll go much deeper into dimensioning and constraints shortly. I just wanted to give you a fair warning about these errors early on because they're common and I don't want you to feel discouraged if one of these errors pops up. They're pretty easy to fix. Okay, so for now, just go ahead and delete this extra learning rectangle that we added here, and we're going to just go back to our one centered square that we have right here. So let's keep moving. Okay, so now that we have our Moonlander base sketched out and we can see that it aligns with the base of our reference image here, the next step is converting this 2D shape into a 3D object. Okay, so to do that, let's just close out the sketch tool here by confirming all of the changes that we've made by clicking on this button here. Now, once we do that, you'll notice a couple of things. So first, you're back in the part design workbench. Second, a panel of modeling tools has appeared on the right. Now, these same tools can be found in the top toolbar right here. So for example, you'll see pad and pocket in both places. Now, it's worth taking a moment to understand how these icons are organized because it will help you navigate FreeCAD much more confidently. Now, the icons are loosely color-coded into groups with dotted vertical lines separating them, though some adjacent groups share similar color palettes, so these dividers are really important. Now, to see the group names clearly, all you need to do actually is just click on Part Design in the top navigation bar, and here you'll find the following groups, which also obviously correspond to the groups that you're seeing right here. So first here we have additive features. Now these are tools that add geometry into your model. Next here, we have additive primitives. Now, these are found over here, and these are predefined basic shapes, things like boxes, cylinders, and spheres. As a side note here, primitive is a term that you're going to hear a lot in CAD modeling. It simply just refers to a basic predefined geometric shape that serves as a building block for more complex models. Next here, we have subtractive features, which again are found over here. Now, these are tools that remove geometry. These are things like the pocket and hole. Next, we have subtractive primitives. Now, these are just primitive shapes used to cut into existing geometry. So next up, we have dress-up features. Now, dress-up features can be found in the drop-down right here, but this group can also be found in the top navigation bar right here. Now, what this group consists of is essentially finishing tools. So things like the fillet or the chamfer tools that refine edges and corners of our model. Okay. Next, we have these transformative features. So these are things like the mirror and pattern tools that duplicate or transform existing geometry. And again, these can be found in the top navigation bar up here as well. So FreeCAD is an incredibly powerful software, but this UI can feel a little cluttered and overwhelming to beginners at first. So just understanding the logic behind these icon grouping, in my opinion anyways, just goes a long way towards making this interface feel a little bit more manageable. Okay, so let's get back into it here. So jumping back in, notice that a sketch item has now appeared in the model tree on the left. This is the sketch that we just created. So what we're going to do here is we're just going to rename it to base bottom. Now, if you made a mistake creating this sketch, what you can always do is you can just double click on the sketch icon, and then you're going to jump straight back into sketch mode. And from here, you can make any corrections. Now, in our case, everything looks good. So let's just close out sketch mode again and then move on. Now, we want to take this flat 2D shape and extend it upwards into a 3D object that matches the base section of our moonlander right here. So to do that, we're going to use this pad tool. So this is essentially FreeCAD's equivalent to an extrude operation. So pad pushes geometry upwards to give it depth and height. If you ever need to do the opposite, cutting downwards through an object, that's what the pocket tool is for. Now, we won't be covering the pocket tool in this tutorial yet, but it's just worth knowing where it lives and what it does. So with base bottom selected in our model tree, click on pad. Now from here, you can either type a value directly into the length field here or drag the arrow upwards manually to set your height. Let's just click on front view now and then drag the shape up until it matches the height of the base section from our reference image. Now, if the perspective looks off while doing this, just make sure orthographic is selected from the view drop down right here. Now, once you're happy with the height, click on OK. Here you'll see the 3D geometry appear in the viewport now, and the pad operator will be added to your model tree with the sketch geometry nested underneath it. Okay, so that's a lot to absorb in one sitting. I'm going to stop there now and we'll pick up in the next tutorial. Next time we'll learn how to create the cutout corners of this base piece here, and we'll also cover how to sketch directly on top of existing model geometry rather than always having to start from an invisible construction plane. For example, we'll use that technique to create these panels, which you see on the side right here. Also, before you go, if you're a designer or engineer and you're looking for help generating product ideas or creating high-end marketing visuals for your existing concepts, come check us out over at Lightloop. We have a growing suite of AI-powered design tools built specifically for product designers and engineers. Again, a link is in the description below. Also, a like and subscribe really helps the channel. I'll see you over in the next one.